Amazing. Thank you.
Thank you. All right. Everyone hear me? We good? Yeah? Awesome. All right. So this is maintaining builds at scale. Who here has more than 100 repos? Oh, everybody. Okay. Yeah. That's why you're here, right?
Yeah.
Who has more than 1,000?
Yeah.
Oh, a lot. Okay. So who has 10,000? Well, okay. I'm not going to go any higher than that, but
does anyone have 100,000? All right, cool. That's truly a lot.
You're right. So we'll hit the next line here. All right. So we were just introduced, but we'll do some quick bios here. I'm Brian. As Julianne mentioned, I'm a beekeeper, and as you can tell by my shirt, I'm a big Maven fan. I work at Gradle, and I talk about Maven, so it's a very fun position.
Hi, yeah, I'm Sam. At one point, I worked at Gradle talking about similar things. These days, I focus on talking about automated code refactoring, maintenance, and all the fun stuff that comes with that.
Great. Okay, so today we're going to talk about a handful of things, basically the problems with scale. So folks that have one repo, anybody have one or two like big mono repos that deal with? A few folks.
All right,
okay.
yeah.
All right, so you have one set of problems, right? So that makes it better, I guess? Maybe better. But it's one set. It's something, if you have 1,000 repos, things get pretty tricky pretty quick, right? So we're going to talk about dependencies and managing those dependencies in your supply chain. Then obviously we're going to talk about open rewrite. Has anyone heard of open rewrite?
All right, right on.
All right. And then of course there's going to be a lot of demos from Sam here.
Yeah. So one thing about software development is that even if you do everything right, you're still going to just run into problems constantly. Talking about automated code refactoring and using automation to improve the quality and up-to-dateness and maintainability of your code, I sometimes run into people who are a bit offended by that premise, like I am saying that their code is bad by suggesting that tools could be used to address some of the tedium or some of the problems that come up. And that's really not my intention, because even if you make all of the best possible choices, you still run into problems. That's just in the nature of engineering, perhaps in the nature of human endeavor writ large. So even if you do everything right, perhaps especially if you do everything right, you succeed and get to a scale where you just have a lot of problems to deal with as just a natural part of that.
All right, so this is a scary graph. Hopefully, maybe not. I love sticking this graph in my presentations. Has anyone seen anything look like this? The number of CVEs, quarterly, monthly, yearly? Yeah. Okay. All right. So if you average out all these data points, there are about 57 vulnerabilities reported every day, right? But this red trend line is going up to the right. And this is only the last few years. So if I extend this out to I don't know, I forget when it was, the late 90s or something when we started tracking these things, it's still going up to the right. So just the last year alone, there's on average 80 vulnerabilities reported every day, right? So how often do you update your dependencies? Do you do it 80 times a day? All right, that's not how that math works, but All right, but anyway, so I'm not trying to scare anybody. I'm just trying to stress the importance of we need to be thinking about these things, and we really need to be focusing on it. But there's challenges here. So hopefully there's a better way to do this, right? Anybody using bots to update dependencies?
Yeah.
A lot of folks.
Yep.
Okay. I love Dependabot. It's great, right? It does a lot of things for me. Dependabot has more commits in some of my projects than I do, and I think that's totally fine, right? But there are some limitations there. Has anyone used Dependabot to migrate between Spring Boot 2 and 3? No, right? How about JUnit 4 and 5? No, right? You did? Dependabot did it. Oh, okay. So you got something else on there, but okay, that's good. But things fall short really quick when there's something other than just the Maven coordinates changing, right? Has anyone not migrated to Jakarta yet? Any Java folks? Okay, so a few folks on Java X?
No.
Yeah, are you going to do that with Dependabot? No. All right, that's a nightmare. I'll complain about this afterwards. We can all huddle around a corner and cry together about this package change and how great it is, but we'll leave that for the outside of the room.
Yeah.
But yeah, so there has to be a better way to do this stuff.
And so Open Rewrite, I would posit, is that better way. Open Rewrite is a system, a set of libraries, and a corpus of recipes for automating changes to code. Open Rewrite is open source. We're there on GitHub under github.com/openrewrite. It's all Apache 2 licensed, so you can use it however you want for commercial purposes. Don't need our permission for anything. And the fundamental purpose of these set of libraries and recipes is to automate the tedium out of software development, right? We are professional automators, right? If we work in software, that's what we do. But I don't know if we like pissed off like a Greek god or something and like got cursed to be professional automators who cannot automate the that we have to do every day. But that has been the case for a substantial part of the history of software development, that programmatically modifying code has been too finicky. You know, if you get one semicolon wrong, you don't have code anymore, you just have a mess. So, you know, typical textual manipulation-based approaches to code modification kind of inherently fall short because code is too structured to have little errors like that. So, or little mistakes in the changes made by whatever your automatic refactoring is. I mean, has anyone ever had to make thousands of changes and only had like a grep or a regex like find and replace to do it with? Like I definitely have, yeah. And you're like, oh yeah, I got this regex down. This is totally gonna do it. And for, you know, 5,000 out of 6,000 cases where your regex makes a change, you might be right. But then you still have that list of 5,000 places. You're like, oh, I didn't anticipate that exact sequence of characters. I got to go do a bunch of stuff manually still. So in order to get us to the next level of being able to automate changes to code, we need a more structured representation, something that programs can work with more fluently and with less error than text. And so that is what we call an LST. And so part of Open Rewrite is parsers that turn source code into this structured LST representation. And there's also the recipes, which manipulate those LSTs to refactor them, to fix a code smell, to update a dependency, to migrate you from Spring Boot 1 to 2 to 3, whatever you might need. And then at the end, that LST is printed back out to source code. And you can run this with Maven and Gradle plugins, as well as some other tools that we'll talk about. And so the LST format, you know, like I was saying, as programmers, we're all familiar with the textual representation of code. And if you work on compilers or parsers or otherwise remember the relevant class from college, you're probably also familiar with an abstract syntax tree. We used to call our data structure just an abstract syntax tree because the way the Java parser works, for example, is we invoke like the real Java compiler, have it parse the code, have it type attribute the code, and then we map it onto our representation, which is format preserving because no one's going to accept an automated pull request from you if you stripped out all of their comments and changed their curly brace placement, right? Like no matter how useful the rest of the change is, they'd just be like, screw off, I don't want you to mess with my stuff like that. So I put in a lot of work to make sure that this representation was format preserving on top of that so that people would be comfortable accepting the changes. And we still called it an AST until someone kind of snarkily said, well, if you're keeping all of the white space and all of the comments, it's not very abstract anymore, is it? And after I got over the sting of that barb, I was like, all right, fair enough, you're right. It's not abstract, it's lossless. And crucially, like I mentioned, it is type attributed, which means that if you're writing a recipe, like you had mentioned log for shell earlier, if you're writing a recipe that does something with logger statements, you can tell the difference between, or the recipe could tell the difference between a log for j, log.info method invocation, and a slf for j, log.info method invocation, which the best crafted regular expression in the world never could, right? So having this format preserving and type attributed representation of your code, which is highly structured, allows you to write programs that make changes with a very high degree of confidence in the accuracy of those changes. Since you don't have to guess or waffle if you're looking at a method invocation in that vulnerable library or not, right? You can be confident. So I've talked a bit about recipes, maybe already casually thrown around that word a little bit, but a recipe is just a program which manipulates LSTs, right? And it might transform them, it might search them, it might extract data from them and put it into a data table, put it into a spreadsheet or a JSON blob if you're looking to query your code or ask a question of your code rather than transform it. So when I say recipe, just think, program that operates on an LST, typically with a visitor pattern, which you may or may not already be familiar with, but, not necessarily. Okay, so that's enough foundational stuff. Let's just start showing how this actually looks in practice. So I mentioned that there's open source Gradle and Maven plugins for running recipes. So everything I'm going to show you today, you can do with your build tool, but I'm going to be using, because it, looks better on a screen, demos better. The Moderne SaaS, which is our hosted SaaS application, which brings together the open source recipe catalog of now some 2,700 recipes in the from around GitHub, with some 32,000 projects that are just public projects on GitHub that we have produced LSTs for and ingested into the system to make easily addressable by recipes. So I think we could just start off with, part of maintaining a build at scale is trying to maintain code quality. And linters have always been a frenemy of mine, right? Like, I like having high code quality, but I felt in my soul a deep loathing for check style the first time I'd worked hard on a change, like for hours and hours, and was getting ready to submit it, and I sent it off, and CI built it, and the build failed, and the error was on line 100 and column 25, you need a space between the if statement and the opening parenthesis, and I was like, if you know so well where the space is supposed to go, why are you throwing up this stupid error message in my face and wasting my time? Just put the space there.
It gets worse when that check style or whatever your linter runs after your build runs. Anybody have that afterwards? So that failure happens an hour later?
Yeah.
Yeah, okay, so some folks.
Yeah, and that sucks just so bad. Particularly those people, I saw the hands for the big mono repos. At the time, I was definitely working on a big mono repo, and if your build takes a while, and then it fails in one of the later stages, you're like, man, you only get a couple tries per workday to deal with something like that. So in the spirit of being a tool that just actually helps you out and fixes it for you, rather than being another tool that complains and adds another item to your already overflowing to-do list, this is our popular common static analysis issues recipe, which combines together several dozen other recipes, each of which fix something that, your check styles or your sonar cubes or your spot bugs or what have you might complain about. And we've tagged, where relevant, each of them with the RSpec, the sonar cube number of the issue that it addresses. So I already kicked it off, and we've got some results coming back on this selection of some 15 repositories I've ran it on. And, so far this recipe run has been going for about a minute, and we estimate that it would have taken a human programmer 41 hours of uninterrupted work to fix or to make all of the changes contained in here. So let's just pop into one of these and, kind of take a look at what we see. We get things like, this is a common static analysis issues one. So we get things like making a class final that could be final, removing the unnecessary initialization of a field to its default value, null, removing an unnecessary type parameter. All the little things that you're like, yeah, that's good for code quality, and you'd be really annoyed if your dang build broke about it later, right? And so, through this system, we could issue an individual commit to this repository, issue mass commits to this repository, or to many repositories, right? Because we ran this on several dozen. So if we're like, yeah, I want to get rid of all of these SonarCube issues across all these repositories, well, boom, we could just go and, well, if I was a direct committer on this selection of Spring repos, I could potentially commit directly. But, since I'm not, I would probably go to creating a pull request from a fork and try to affect change that way. So, yeah, I'm fine with interruptions basically anytime. Any questions about what I've seen so far? Or we could just kind of keep them all for the end. Yeah, question in the middle there. Yeah, so the question is that I showed a recipe that combines other recipes. How do you write a recipe from scratch? So if I go back to this recipe anywhere on this interface, and indeed also on docs.openrewrite.org, which I should show briefly, this is the Open Rewrite documentation. So if you want to learn anything about recipe authoring or how this system works, how to get into writing your own recipes, come check this out. But on any recipe definition, at least in the SaaS, if you go up here, you can say view recipe source. And since all the recipes are in open source, it'll take you to the file which defines this recipe. Now, this guy being a YAML being a composite is typically just a YAML file that lists the other recipes that are part of it. It's just a convenient way to make aggregates. Most recipes that actually do the work of making a code change are typically written in Java. So if I go to, but they could be any JVM language, and indeed now C# as well, as we were expanding into that. So this is what the actual implementation of one of these recipes look like. You got some metadata, and then I mentioned earlier there's a visitor pattern So this recipe changes method invocations. So since method invocations are what you're interested in, you can just override visit method invocation. And this points to something, I think, important about the nature of recipes, which is that for the most part, these are programs that are written, tested, debugged by humans. And you can use AI in this process, but to get like the high level of accuracy in changes, to get things correct and to be confident in the correctness of the changes, we tend to use AI more to like get started with a recipe or produce a list of recipes rather than to make the changes themselves. So you don't have to worry about hallucinations, or rather, if there were hallucinations, it wouldn't be in making the change itself. It would be something that you as a human programmer could review and fix before continuing to go and use it to transform your entire code base. So static analysis is great, but we're here at a Gradle conference. We're kind of talking about dependencies and keeping dependencies up to date. So one thing that is, no like migration to the latest version of Spring Boot or Java or whatever would be complete without being able to do dependency updates. So part of what's included in these LSTs for a typical project is not just the source code, but also all the data files that go along with it. Now, your Spring YAML configuration, your properties files, and of course your Maven POMs and your build.gradles, so that recipes can do dependency updates, and so that recipes can modify. If you have your use GitHub Actions and have YAML files checked into your repository that represent your CI, can update that as well. So like if we go to like run the migrate to Java 21 recipe, just like the other recipe, it is a composite of many other recipes, starting with migrate to Java 17 and then adding in all the Java 21 kind of specifics. I'll go ahead and kick that off so I can start running.
While it's running, who's still on Java 8?
Yeah.
Who else doesn't want to admit it?
Who we got on Java 11 still? Yeah, I got a couple people. Who's on Java 17? All right, yeah, good job. Who's on Java 21? All right, yeah, right on. So we got like the full kind of like spectrum.
Any 23ers?
All right,
Really?
Early adopter in the back. Good for you.
Right.
But yeah, for most organizations, or for many large organizations, it's hard to raise your hand in just one of those spots. It tends to get kind of spread out, and the answer is often all of them or a selection of several. So anyway, let's look at some of the results we've got coming back from the Migrate to Java 21 recipe. And this will do things, both the absolutely necessary transformations, like replacing a Java X to Jakarta, and getting off of some deprecated method for its replacement, as well as taking advantage of some of the new features. Like using get first instead of get zero on a collection. Things like, a lot of get first in this one. That's a pipeline. Oh, yeah, paths.get to paths.of. So it looks like this repository is already pretty Java 21ified. Let's see what we got in Spring Data Commons. Might get some. I didn't prepare which repositories I'd look at in advance. Oh yeah, string.format to string.formatted. If we scroll a while, we might find a multi-line string concatenation being turned into a text block. And we find that mixing in taking advantage of the new features of the new release, in addition to the strictly necessary things, to be just beneficial for everyone, right? You've got developers, I imagine like many of you, who are here at a conference interested in being on the cutting edge and learning what the new features of any given library are. And then you have people who maybe don't take as much initiative to stay up to date on what the latest cool things are. But if you've used a recipe that introduces the new features of the new library into your code base, even people who aren't out there reading the release notes in the latest version of Java or Spring or whatever will see those features in use and kind of by osmosis get to learn and benefit from them, from seeing them in their appropriate context within your code base. Cool. So yeah, we were talking about dependency upgrades earlier, and particularly about security issues. So another very popular recipe from this corpus of recipes is the find and fix vulnerable dependencies. And thank you for your patience for me sounding out those words. I find I cannot speak one set of words and type a different one. So this guy, and I'm going to kick that off. So this guy goes and compares your full transitive dependency closure to the GitHub Security Advisory database, which aggregates vulnerability information from several other databases, but chiefly the National Vulnerability Database, which is the source of truth for those CVE numbers that we all know and love and have to deal with 80 new ones a day. And this guy does a mixture of reporting on what it finds and fixing kind of opportunistically whatever dependencies it can while minimizing the risk of breaking change. So we've got some of these results coming back already. Let's see what we got. Yeah, so you will see that it will try to bump the versions of dependencies that are known to the database to have potential vulnerabilities. When the version delta between the version you're on and the version that has the fix is small, according to Simver, which is to say it will try to do patch version bumps, since the library authors are asserting that there should be no breaking changes in patch version bumps. And yeah, so this one was a Maven POM where we updated direct dependencies. Let's see what we get over here. There should be some Gradle ones mixed in too. Yeah, and here we go. So here's a Gradle one, which will do not just your direct dependencies, but also, we see a direct dependency update for Xstream here, but also takes advantage of the constraints mechanism in Gradle to update the versions of transitive dependencies, so that, your vulnerability scanner's not going to complain only about direct dependencies, since direct dependencies are not your entire runtime class path, but also about transitive dependencies. And so we can influence the versions of those through mechanisms like this. Now, that's great, and just running this can, you see how long, when the Gradle public API gives a place in the constraints to give a reason to select that version, and so we have the recipe to stick the CVE numbers in there. As you can see, that just one little version bump can end up fixing a surprisingly long list of potential CVEs. A serialization library is always going to be a popular place to find potential vulnerabilities. So yeah, that's a long list of things that you could just make disappear from your security reports that management and the security team is fretting about and hassling you about with just the click of a button. I'm going to cancel the rest of this recipe run so that we can get directly to one of the other artifacts that a recipe run can produce, which is a data table, something I alluded to before. Now, these data tables are kind of an optional artifact that any recipe could choose to produce alongside a diff, a patch file, a set of changes. And this is, tabular data that you can go and open up in Excel or your business intelligence tool of choice. And the recipe can then produce a report on kind of whatever domain it's interested in. The first few columns are shared between all data tables that any different recipe would produce. Then identify which repository the rest of the row is from. And then you get into the stuff that is specific to that particular recipe, which, since this recipe is focused on doing dependency updates for security purposes, it has CVE information and like the number of the vulnerability, the GAV coordinate of the potentially vulnerable dependency, summary of the issue, and if a version is known to have a fix, what that fixed version is. And so this is kind of what we look at to say, should we attempt an automatic version update in the build file because this version is small. But the report contains the full set of potentially vulnerable dependencies that were discovered, not just the ones we were able to change in an automated way. And on top of data tables can be built data visualizations. So this visualization that I've just kicked off is a Jupyter notebook, which is a popular data analysis and visualization kind of system written in Python. If you have any data analysts at your company, they're probably already familiar with creating Jupyter notebooks. And this is operating on that same data table we just ran, and is bucketizing kind of again by how big of a version bump is required. Each of the vulnerabilities into patch version bump, minor version bump, major, or not yet any fixed version. And so you can see for this set of repositories, just bumping patch versions on a regular basis could wipe out just a pretty decent chunk of the entries in these vulnerability reports while minimizing your exposure to potential breaking changes. And I've gotten some requests to augment the recipe to provide an option to, if you're feeling a little riskier, also do the minor version updates. And so, maybe you'll see that as an option coming to the recipe as well. And of course, no migration would be complete without being able to get on the latest version of Gradle. So we also have an update Gradle wrapper recipe, which we have a Gradle power user in the open source community. Or in the open rewrite open source community. So often the way that we find out that a new Gradle version has been released is, I don't know if this guy is just like always watching for a new Gradle release. He must have an RSS feed or something because like the minute a new Gradle release comes out, he issues pull requests to all open rewrite repositories to bump us up to the latest version of Gradle, by running this recipe. So let's see if I can just go ahead and run this on this selection. And I'll just say go ahead and add it if it's missing. So even the Maven projects in here might get a little Gradle wrapper added to them. Yeah, boom, there we go. Got a result already. So this guy will go and update the version of the Gradle wrapper you use. Yeah, boom, this guy went from 8.7 to 8.10.2 and added the distribution, the checksum to it so that, you could have that verify Gradle wrapper integrity action, make sure that this hasn't been tampered with by anything. So I hope this kind of short demo kind of shows you a glimpse towards what I think will be the future of software development, which is kind of shifting some of the responsibility for breaking changes left from the developers who use and consume libraries to the developers that maintain and publish libraries and platforms. Because the leverage, the way that, libraries are just magical, amazing things. I don't have to write my own cryptography. I don't have to write my own networking stack. People better than me at those specialties have already put a lot of work into doing that really, really well. But if I lost my train of thought.
The library developers.
Right, shift and left on the library developers. Well, library developer can make a breaking change, and then 100,000 users can have to deal with it, right? That leverage really sucks. And as a library author, and as a software developer, I tend to know the right way to do some new API to provide some piece of functionality after I've already built it once, right? And then I immediately have a dilemma of like, okay, now that I built it once and poorly, do I then kind of screw my users by immediately announcing breaking changes that my early adopters have to deal with? Or do I screw my users by sticking them with a bad API that I designed when I didn't yet know what I was doing? But if recipes and automated software changes and updates can make breaking changes less painful for people, then how much more creativity, how much more safety net, the ability to innovate boldly and with confidence that I won't have to have this horrible dilemma of bad API or breaking changes. And we can get to a place where software is just a lot more fun for everyone, and we don't have to deal with all of this tedious bullshit. We could finally break the god's curse upon us and automate away our own tedious tasks as well. And if you're interested in learning more about this, we have a book about combining these techniques with AI that I encourage you to check out. And we Moderne will be having a Code Remix Summit in May 2025 in Miami, Florida, to talk about this with our open source community and our customers and interested software engineers from all over. So I encourage all of you to check out both of those things and check out Open Rewrite. And I'll be around, so come talk to me. And
so in the past year or so, a few folks over at Gradle, we've been working on training courses. So it's at dpeuniversity.gradle.com. Scan the QR code. But there's courses on things like flaky tests, build skins, Maven build cache, and of course, as you would expect, a bunch of Gradle intro classes too, and we're adding more. So definitely check that out. And is there any Maven fans in here? All right. There's also a Maven Power Hour at lunchtime. So it's grab your lunch, and I think it's in this room. Check the Wova app. It's just kind of birds of the feather type of thing. Where no real agenda, just kind of open conversations. Or if you just want kind of a nice place to eat and talk with some cool people, you can do that too.
Right on. All right. Well, thanks, Brian. Thank all of you.